Hey, pre-algebra, it's time to keep moving in chapter 9 on 9.7. Please make sure that you have 9.7 open. It's on page 378 in your textbook, and you have your direct variations notes ready to go. Okay, first off, we are going to start right away with some definitions, all right? The variables x and y form what's called a direct variation if the ratio of y to x always equals a constant, which we call k, just like we call slope m, we're going to call the constant k, where k is a positive number. The variable y is said to vary directly with x, or x and y are said to be directly proportional. The constant k is what we call the constant of variation, or sometimes it's also called the constant of proportionality. Okay, more often than not, you're going to see it called just the constant of variation. Very rarely will you see this constant of proportionality. Okay, so let's take a look at a table. Okay, this table includes the number of miles traveled, y, in a certain number of hours, x, at a constant rate of 30 miles an hour. That means someone is traveling for a total of 4 hours. They're covering a certain distance, okay? But they're traveling the entire time at 30 miles an hour. Watch what happens. The first hour they're going, they cover 30 miles, okay? When we make that ratio to figure out what k is, remember y over x is equal to k, you'll see we have 30 miles over 1 hour, which is equal to 30, okay? In their second hour, by the end of their second hour, okay, they will have traveled 60 miles, right? So 60 total miles of distance covered over 2 hours is equal to 30. At the end of their third hour, they will have traveled 90 miles because they're traveling 30 miles every hour. Apparently there is no traffic, no little geese in the road trying to cross the road that they have to stop for or anything, no red lights. They're also going very slow for some reason, but whatever. 90 divided by 3, y over x, gives us a constant of k, and then pretty sure you figured out what's going to happen here. We've covered 120 miles in a total of 4 hours, so our ratio of y to x is equal to 30, which is our constant rate of k. Since the ratio of y over x always equals a constant in the general form of the equation for a direct proportion, we represent it with the letter k. So y over x is equal to k. What happens if I solve this equation, though, for y? If I want to solve this equation for y, I multiply both sides of the equation by x, and then we get y is equal to kx. So now I have a new form or a new equation for our table that we just worked on. Remember, we figured out with our table that y over x was equal to 30. If I multiply both sides of this by x, x cancels out and we get y is equal to 30x. If y is equal to kx, in this example, k is equal to 30. Example number 1. Does y vary directly with x? If so, find k, which is the constant of variation, and write an equation for the direct variation. Question number 1 in here says, does y vary directly with x? We say yes to that if k is the same between every y and x relationship, okay, as we move through our table. So let's look at that. Here we have pair number 1. X is 1 and y is 3. So when we set up the ratio of y to x, we get 3 over 1, which is equal to 3. Let's look at our second pair. We have 3 and 9. So let's set up our ratio of y to x. 9 over 3 is equal to 3. Let's look at our third pair, 5 and 15. Set up your y over x ratio. 15 over 5 is equal to 3. And finally, our last pair is 7 and 21. Set up your y over x ratio. 21 over 7 is equal to 3. We have a constant of variation here. It is the same between every one of our pairs. That means in this table, y varies directly with x. So the answer is yes. This does represent a direct variation. Now, we have already found our k because we established our ratio of y to x as we moved through our table. So k in this table is 3 because y over x is equal to k. Now, write an equation for the direct variation. Equations for direct variations come in the form of y is equal to kx. So all we do is substitute the constant of variation that we figured out into our equation. Y is equal to, what was k? 3x. So, one more time. Does y vary directly with x? It sure does. If so, find k. Y over x, in this case, k is 3. And write an equation for the direct, that was number 2, sorry. Write an equation for the direct variation. Y is equal to 3x. Skill check number 1. Box skill check number 1, let's look at number 1. Here's the table, okay? Take a look. Does this represent a direct variation? Remember, what that means is that every time I divide y by x, I'm going to get the same thing. I'm not even going to start working through division because I want you to be able to identify right away this is not going to work out because there's no possible way that 12 divided by 3, which is 4, okay? There's no possible way the quotient of 12 divided by 3 can equal the quotient of 20 divided by 3. So, nope. This is not a direct variation, okay? Let's move on to number 2. First glance, I'm pretty sure you already know what the constant of variation is and that this does represent a direct variation, but let's just work through the steps. If it represents a direct variation, that means the ratio of y to x is going to equal a constant k that is going to be the same throughout our entire table. 6 divided by 1, 12 divided by 2, 18 divided by 3, 24 divided by 4. 6, 6, 6, 6. So, yes, this is a direct variation. 2. What is k? Well, k is equal to y over x. Remember, y over x is equal to k, which we figured out in each one of these. K is equal to 6. Third part, write an equation for the variation. Remember, our equations for direct variations are y is equal to kx. Substitute 6 for k. Y is equal to 6x. There is our equation for this direct variation. That means if I'm given any x that is a part of this relationship, I can figure out what y is simply by plugging in for x. Example number 2, okay? Indicate which of these equations is a direct variation, okay? If so, identify or find what k is. Working through this example is going to give us a couple rules that we need as we work through direct variations, right? Number 1 says f of x is equal to, or a, f of x is equal to 2.2 times x. Remember, f of x is synonymous with y. So this is y is equal to 2.2 times x. At first glance, most of you are going to say, yep, this is a direct variation, okay? It is not. And the reason that it is not is because k cannot be a decimal. K cannot be a decimal. So this is not a direct variation. B, y is equal to 4x minus 1. Is this a direct variation? Nope. The reason that it is not a direct variation is because we have this added -1 here. That negates the idea of this being able to be a direct variation. The variable y has to simply be a multiple of x, and that's it. This -1 negates that, so this is not a direct variation. C, d is equal to 45t. Is this a direct variation? Absolutely, absolutely. And it's okay that you don't have y is equal to 45x. What this means is that d has a proportional relationship with t, where d is always t multiplied by 45. Our direct variation says no matter what, we have a proportional relationship where something is always equal to a variable multiplied by a constant of variation. All right? What do you think this is? Does this look familiar to anyone? It should. Okay? This is actually distance is equal to rate times time. Distance is equal to rate times time is a form of a direct variation. So d is equal to 45t. 45 stays constant no matter what. Yes, this is a direct variation. Last one, d. Y is equal to -2 over x. Is this a direct variation? Nope, because in our definition of a direct variation, we stated that k has to be positive. The coefficient of x, which is the constant of variation k, has to be positive. -2 is negative. This is not a direct variation. Okay? Now, let's look at box skill check number 2, number 1 through 4. Indicate if the equation represents a direct variation. If it does, what's the constant? So number 1, y is equal to 3.5x. Is this a direct variation? Yes, absolutely it is. What is the constant of variation? The constant of variation, k, is equal to 3.5. Number 2, c is equal to pi times d. Is this a direct variation? Yes. C is always the product of a constant multiplied by d. What is our constant in this case? What is never going to change? Pi. Pi is never going to change. So this is in fact a direct variation where your constant of variation is pi. Number 3, y is equal to 2x plus 7. Is this a direct variation? Nope. Because of this. Wah, wah. This is not a direct variation. Number 4, xy is equal to 100. Is this a direct variation? No, it is not. Okay. Moving right along, take a look at the similarity that we have between y equals mx plus b, which is slope intercept form, which you worked on in 9.6. This is the slope intercept form of a line. And here's our equation for a direct variation. They look pretty similar with the exception of the fact that we have this plus b in our slope-intercept form. Okay? A direct variation is an equation of the form y equals mx plus b where b is always 0 and m is greater than 0. Okay? It's as if we could write in this plus 0 here, all right? So a direct variation is an equation of the form y equals mx plus b where b is 0 and m is greater than 0 because in a direct variation, k always has to be positive, so it's greater than 0. Therefore, its graph, or the graph of a direct variation, is a line with a y-intercept always at 0, 0, because remember, b is always or our y-intercept is always at 0, b, okay, and a slope of k. So example number 3 says graph y equals 4x. So really, if we wanted to think of this in slope-intercept form, we could just pop in our 0 if we want to. Y is equal to 4x plus 0. So our y-intercept is 0, 0, and the slope of our line is 4, which notice m is equal to k. So let's go over to our graph. Here is 0, 0, and you have a couple options. From that 0, 0 point, you can use your knowledge of rise over run and just go rise over run on your graph, or you can make a table of coordinate points. I think it's way easier to make a table of coordinate points. Just pick very simple values to plug into your y equals 4x equation. What if x is negative 1? If x is negative 1, that means I plug in negative 1 for x, and y is negative 4. If x is 0, y is 0, we already know by definition we have to have 0, 0. What if x is 1? If x is 1, y is 4. I have 3 very easy points to work with. I've already popped 0, 0 in my origin. Then I go to negative 1, 1, 2, 3. Here's negative 4, so here's negative 1, negative 4. And then I'm going to go to 1, 4 right here. And connect my dots. And I have graphed the direct variation, y is equal to 4x. Box skill check number 3, I'm going to go ahead and do number 1 here. It says y is equal to 3x. Okay, y is equal to 3x. Sorry, had to get my bearings for a minute. Let's figure out some nice, easy coordinate points to work with. Let's say x is negative 1. If x is negative 1, y is negative 3. We know 0, 0. If x is 1, y is 3. 0, 0, negative 1, negative 3, 1, 3. Boom. Here we go. Graphed it. You work on number 2. Example number 4. Find k if y varies directly with x. So we know when it says that we're dealing with a direct variation. So find k if y varies directly with x and y equals 12 when x equals 1/2. Write an equation for this direct variation. How do we find k? The ratio y over x is equal to k. We are given 12 and we are given x. 12 divided by 1/2 is equal to k. That is 12 divided by 1/2, which is 12 over 1, times the reciprocal 2 over 1, which is 24. So k is equal to 24. That is 12 divided by 1/2. Equation for direct variations are in the form of y is equal to kx. Substitute 24 in for k. Y is equal to 24x. Here is the equation for this direct variation. Example number 5. If y varies directly with x, so we're dealing with a direct variation, and y equals 6 when x equals 2, find y when x equals 2/3. First step here is we have to figure out what k is, because in order to do this, I have to come up with my equation for this direct variation in order to figure out what is y when x is equal to 2/3. I can't do that unless I know what k is. So step number 1 is establish what is k. If y varies directly with x and y is equal to 6 when x is equal to 2, 6 divided by 2 is 3. So k for this variation, our constant of variation k, is 3. Step number 2, write your equation for this direct variation in the form y is equal to kx. K is 3, so y is equal to 3x. Step number 3, Find y when x is equal to 2/3. Y is equal to, k is 3, right? Y is equal to 3 times, substitute in x, 2/3. Y is equal to 3 over 1 times 2/3. Those 3's are going to cancel each other out. Y is equal to 2. There's your final answer for example number 5. Skill checkbox number 4. I'm going to go ahead and tackle number 1 in there. Find k if y varies directly with x and y equals 18 when x equals 4. Ratio of y over x is equal to our constant of variation. So 18 over 4 is equal to k. K is 4.5. I'm going to skip number 2. If you want to tackle number 2 and figure it out, make sure that is your final answer. Number 3, if y varies directly with x and y is equal to 5 when x is equal to 10, find y when x is equal to 22. Okay, so we're dealing with a direct variation here. Step number 1, figure out what is k. Y over x is equal to k. So if y varies directly with x and y is 5 when x is 10, that means 5 over 10 is equal to k. 5 over 10 is equal to 1/2. So k is equal to 1/2. Step number 2, write your equation for this direct variation in the form y is equal to kx. Y is equal to 1/2 x. Step number 3, find y when x is 22. Y is equal to 1/2 times x. I'm just going to go ahead and write that as 22 over 1. Cancel 2 and 22. Y is equal to 11. There's your answer. Tackle number 4 for practice. When you do, make sure your answer is y is equal to 8.8. I need to swipe back and apologize to you really quick because I did something wrong. Here we go. I don't know why. Probably because, chemo made me do it. Coronavirus crazy made me do it. I don't know. You guys, this one, why did I say that this is not a direct variation? K absolutely can be a decimal or a fraction. I don't know why I said that. Please, please, please forgive me. Yes, this absolutely is a direct variation. Okay, I'm so sorry to have been confusing. K can be a decimal. It can be a fraction. It cannot be negative, so it has to be positive. K cannot be negative. Okay? K can be a decimal, K can be a fraction, K can be positive, K cannot be negative. Sorry to have added that little piece of confusion.